All right, this is our presentation on glycolysis for chapter 8. I am Jake Nitchie, and this is
Levi Holden.
so Levi's going to start.
So let's first off with what is glycolysis? Well, it is the most common pathway used to break down glucose. This is enabled by the help of enzymes, as we will discuss later on. Next slide. So talking about breaking down is catabolism. It's the breakdown of molecules within a living organism to form simpler ones, result in the release of energy. And then this energy can be used or stored for later purpose.
So glycolysis is glucose that is enzymically converted to pyruvic acid. So the first phase is going to be aerobic respiration, which is the primary metabolic pathway. From there, it synthesizes a small amount of ATP anaerobically, and then pyruvic acid is the essential intermediary metabolite in this whole process. So we're going to talk about the first form of glycolysis, which would be the aerobic respiration. So here, chain reaction that is resulting in conversions of glucose into more simple forms like oxygen. This prohibits cells to retain a significant amount of energy. As you can see in the graph here, it starts in the mitochondria in the systole. So then it starts with glucose, goes into pyruvate, and then the NADH comes over to oxidative phosphorylation. That pyruvate goes to the citric acid cycle or the Krebs cycle, then releases NADH, and then also releases FADH2, and then moves into that oxidative phosphorylation, which gives us the ATP. Next, we're going to do the anaerobic respiration. In this one, anaerobic respiration, it uses glycolysis first to break down glucose into pyruvate and energy to yield 2 ATP molecules. In this one, so we go from glycolysis with the glucose, making the 2 ATP, breaking down into ADP, and then releasing the NADH and the NAD in that cycle. And then from the ATP and ADP, we go into the pyruvate, making 2, and then it skips that oxidative process and goes into the fermentation, releasing either lactate or ethanol. And then the subproduct would be the CO2. So now the fermentation process, and the difference is the fermentation takes organic compounds and then goes into glycolysis and then branches off into pyruvic acid. And if it doesn't use oxygen, it goes to fermentation, which then, like we just said, releases lactic acid or ethanol. But if we go down the avenue of respiration, it goes from glycolysis to pyruvate and ATP, and then it uses the oxygen, and then it can release up to 36 ATP molecules, and it also is releasing CO2 and hydrogen, or H2O. Here we go.
Perfect. The enzyme role in glycolysis. There's enzymes involving glycolysis are kinase, mutase, and dehydrogenase, cleaving enzymes, isomerase, or enolase, and they will split or rearrange intermediates to add on phosphate groups and to move those phosphate groups onto ATP to make ATP.
So role in what pyruvic acid does is utilized in several different pathways by many different organisms. The strict aerobes and some of the anaerobes send pyruvic acid to the Krebs cycle for processing and energy release. And the facultative, right? Did I say that right, Levi?
Facultative, yeah.
Facultative anaerobes reduce the pyruvic acid into acids or other products. And then we have a little video here that you guys can watch that kind of really makes the glycolysis processes very fun and kind of easy to understand. So we're going to play that real quick.
Hey, sugar. Come on over here, sweetie. Let's break it down. Glycolysis is a series of reactions, enzymatic actions, energy transactions. Takes glucose, a molecules of sugary, breaks it down to NADH and ATP. It's an anaerobic cytoplasmic pathway that amazes. Organized easily into 3 phases: investment, cleavage, and energy harvest. Tell me later which one you like best. Investment, activation, energy supplied. Cleavage, our 6 carbon sugar divides. Harvest, we get our energy yield. So beautiful, so intricate, keep your eyes peeled. Glycolysis, come on sugar for the breakdown. For the breakdown. Investments, like striking a match. That energy you put in makes the fire catch. For glycolysis, investments to ATPs, which act as activation energy. Enzymes take phosphates from ATPs, jam them on a glucose, rearranging it to fructose, leaving fructose 1,6-bisphosphate on the table with 2 phosphates. It's highly unstable, moving us to the second phase, the cleaving of fructose bisphosphate, because glycolysis means splitting sugar, you can see. Cleavage yields 2 molecules with carbons 3. One is glyceraldehyde 3-phosphate G3P. It continues on our pathway broken down for energy, but the second one, an enzyme, will immediately convert into a second G3P. Glycolysis, come on sugar for the breakdown. For the breakdown. Phase 3, G3P gets rearranged and oxidized by an enzymatic assembly line that harvests energy from each G3P, 1 NADH and 2 ATPs. Double this yield for G3P to 2 NADH and 4 ATPs. That's the gross yield for every glucose in. A generous accounting of glycolysis' win, but 2 ATPs were invested in phase 1, so you net just 2 you can use to jump or run. Put 2 in, get 4 out, your net gain is 2 ATPs that you can use. If that doesn't seem like very much, it's 'cause it ain't. There's tons of energy left in pyruvate. The 2,3 carbon molecules we're left with at the end, and what happens to pyruvate's going to depend on the metabolic pathway where pyruvate gets sent. If it's anaerobic, it'll be fermented, but in aerobic cells, pyruvate's termination will be the Krebs cycle and total oxidation. Glycolysis, come on sugar for the breakdown. For the breakdown. Glycolysis starts with investment of 2 ATPs to the glucose that we started with. The product is cleaved into 2 G3Ps from which the cell harvests NADH and ATPs. This anaerobic pathway is respiration's first phase, billions of years old, evolved in ancient days before O2 accumulated in the seas, before eukaryotic cells arrived on the scene. It's everywhere, ubiquitous in every organism. Bacteria, sequoia tree, no matter your metabolism. Happens in the cytoplasm, doesn't need no organelles. You want to find glycolysis? Look in any cell. Glycolysis, come on sugar for the breakdown. For the breakdown. Glycolysis, come on sugar, come on.
Wow, what a great entertainment value from Mr. Wolkenfield.
Honestly, though, that was the best.
Well, I hope everyone found this presentation helpful, and thanks for listening.